Welcome back to Applied Mathematics. In this video, we're going to be dividing by a monomial. We've talked about how multiplying a polynomial by a monomial is just an application of the distributive property. And while the distributive property for multiplication gets all of the limelight, there is a distributive property for division. You just have to be a little bit more careful about it. Let me get my head out of the way and I'll show you what I mean. The rules of adding fractions. If I have something like 3/7 plus 2/7, I would write that as 3 plus 2 all over 7, which gives us 5/7. And of course, no one at this point in your mathematical careers is writing out that second step, but you know it's there. Another rule of mathematics is that there is no direction. We can follow this down line by line, but if we are simplifying an expression, we are saying that each line is equivalent to the one that came before it and the one that comes after it. So we could just as easily go in the other direction. And that's exactly what I want to do. I want to take something like 12x minus 15 all over 3 and rewrite it as 12x over 3 minus 15 over 3. Of course, 12 divided by 3 is 4, so 12x divided by 3 is 4x, and 15 divided by 3 is 5. So we can distribute the division. The reason that this doesn't come up as much is that division is a little bit particular about order. Right? When you're multiplying, which number comes first and which number comes second doesn't matter. When you're dividing, which thing is on the top and which thing is on the bottom does make a difference. So the distributive property here is only useful when the denominator is a monomial. When you have a more complicated expression in the denominator, you need a much more complicated process of solving it. That process is a little bit beyond the scope of this course. But even within this, we can do a lot. I can take something like 3x squared plus 12x minus 21 and divide it by 6x. I can split that up, 3x squared over 6x plus 12x over 6x minus 21 over 6x. Right? 3 over 6 is a fraction that reduces to 1/2. X squared over x is x. 12 over 6 is 2. X divided by x is x to the 0, which is just 1. I don't bother writing down 1. 21 over 6 is a fraction that reduces. It's going to become 7 over 2. And then we have that factor of x, but it's hanging out in the denominator. Cleaning up a little bit, I might write this as x over 2 plus 2 minus 7 over 2x. Is that actually simpler? Well, I don't know. That depends on your application. There are some places where having this expression is going to be much more useful. There are some places where having this expression is going to be far easier to work with. It all depends on context. Right now, we are in the building block phase. I want to show you the mathematics toolkit. I want to show you that you can play around with these sorts of things so that in a future mathematics course, you understand what's going on and you're comfortable and you're able to go through the processes. Let's look at one more example here. 6x squared plus 10xy minus 14y squared all over 4x squared y squared. Using the same rule we've been talking about, I can split this up. 6x squared over 4x squared y squared, 10xy over 4x squared y squared, 14y squared over 4x squared y squared. In the first fraction, 6 over 4 is a fraction that reduces to 3 over 2. Then there's an x squared in numerator and denominator that are going to cancel each other out. And then you have a y squared left behind, which is in the denominator. In the second fraction, you have 10 over 4, which reduces to 5 over 2. You have x over x squared, which is 1 over x. You have y over y squared, which is 1 over y. You have 14 over 4, which is a fraction that reduces. It becomes 7 over 2. You have an x squared in the denominator. You have y squared divided by y squared, which cancel each other out. All right. Cleaning these fractions up a little bit. 3 over 2y squared plus 5 over 2xy minus 7 over 2x squared. Again, context is key here. It's never immediately apparent whether this has made things better or worse. It's just made things different. And the context of why you are looking at this expression will tell you whether something like this or this is the more useful thing, or whether it would have been better to leave it in the original form. All right. For right now, though, that's all I have. So as always, thank you for joining me, and I'll see you in the next video.